Hi, everyone. As Gabe said, my name is Robert Tadlock. I'm the director of our consulting team here at TechSoft. I'll be giving the presentation today, and we're going to be discussing kind of some web architectures with HOOPS Communicator and specifically setting up reverse proxies, which is a question we get fairly often. So the agenda today is we're going to do a quick introduction, give you a bit of background about who I am, what I do at TechSoft, etc. I'd like to do a quick review of HOOPS Communicator, the architecture, the different components. I like to do that for every webinar or anything that I give here, just in case we have new people who are not familiar with the technology. From there, we're going to discuss kind of what's the problem that we're trying to solve, what's the scope of the learning today. We're going to be using a tool called Reverse Proxies, so I'd like to give you a little information about that. Then we'll kind of talk about a few different example web architectures that you may use, as well. We'll have a little bit of a discussion about the different components that may make up your architectures, things that are optional, things I feel like I recommend, or I think everyone should use, kind of things like that. Then we're going to walk through an exercise. So I've set up a reverse proxy with HOOPS Communicator, and I'll be walking you through kind of what that looks like, some of the configuration changes I made with HOOPS Communicator, as well as some of the configuration changes with Nginx, which is the tool we'll be using to proxy our connections. At the end, we'll be talking about kind of additional resources that you might look into after this webinar. I'll be making all of the files that you see today available for everybody. So stay tuned for that. You'll be able to download those. And then I didn't put it here, but we'll leave some time for questions at the end. So my name's Rob Tadlock. I've said that a few times, but I've been at TechSoft 8 years. My background is that I was a software engineer for 5 years, and then I moved into technical sales. I did technical sales at a few different companies, and then I moved to TechSoft, where I've been for 8 years, actually, in July. And I like to measure my time by sabbatical length. And here at TechSoft, we get sabbaticals every 4 years. And so I'll be doing my next sabbatical this summer, actually. Pretty excited. Most of TechSoft is remote, especially post-COVID. My team has been remote prior to that. The consulting team spans the globe. We've got a few people in the US, a few in Europe, and then one in Japan who manages our APAC region. I work from home in Colorado. I live with my wife, 3 cats, and my dog that's running back and forth there. I have a lot of hobbies. I kind of like the learning process. I do jujitsu. I like to do a lot of outdoorsy things like canyoneering and hiking and climbing and mountain biking. I also like to code on the side, do some sewing, and I recently just got into lockpicking, which has been a fun thing to do on Zoom calls. I know I should be paying more attention, but it is what it is. So let's move on here. And the next thing we're going to move through on the agenda is the overview of HOOPS Communicator. So there's basically 3 main components to this tool. And HOOPS Communicator is an SDK that enables applications to move into the cloud and start to display, render, and interact with engineering data, CAD models, PMI, that kind of stuff in the cloud in a web browser. It's made up with 3 components here. We've got the WebGL viewer. That's pretty straightforward. That's embedded in the web browser. It's on the client side, and it is kind of responsible for displaying all of the CAD data, PMI, views, attributes, measurement data, markup, any of the things that we do in HOOPS Communicator. So when a lot of people think of HOOPS Communicator, they think of it as a web viewer, but it is indeed more than that, and as you'll see here. The next thing is the HOOPS server, and oftentimes you just hear people say we have a client server architecture, and we speak of the server often as it's a single component. In fact, it's made up of 3 different components here, as delivered from in our quick start package and in a lot of our sample applications. There's the HOOPS streaming cache server, which is actually reads the stream cache data on the server and streams it down to the viewer. And stream cache, by the way, is our file format that we convert all the engineering data into, and allows us to have high performance rendering with large data sets. We won't go too far into depth about that today, but if you've got questions or would like to discuss more about that, you can put it in the chat and I can send you some links to learn a little bit more about that. The next component is the HOOPS server. This is primarily responsible for orchestrating the stream cache servers on the back end. So a stream cache server is generally one stream cache server for one viewing session. And obviously, if you've got a multi-tenant application, which most web applications are, you're going to need to run and manage the lifecycle of multiple stream cache servers on the back end. And that's where the HOOPS server comes in. So the HOOPS server has a REST component and things like that. And we're going to go a little bit more into that. We also deliver a file server with our quick start and sample applications. This is primarily for convenience so that you can easily get up and running. Most companies, partners of ours, will replace this with something a little more standard like Apache or Nginx or IIS or something like that. Lastly, we have the data authoring tools. And I mentioned stream cache earlier. These are the tools that allow you to ingest data into the system. So, CAD data, you might have polygonal data. We have tools that allow you to write your own importers. So from your proprietary formats, things like that. These are the behind the scenes for most people, but they're really important in the architecture of HOOPS Communicator. And it's a large part of your application, because in order to view things on the web, you need to prepare the data, and you do that with these tools. So we deliver a binary, which I think the majority of our users use. It's called Converter. It has a whole bunch of command line options. It allows you to pick and choose what things you want to pull from the CAD data and put into the stream cache file. You can choose, I just want the geometry, I just want tessellation, I want the PMI, I want all of the above attributes, things like that. There's also a lot of different options on generating, say measurement data or, levels of detail. It's a pretty versatile tool, and there's a long list of command line options in our documentation. Again, we ship some pretty complete samples for that in our package. So when and if you start to use or evaluate HOOPS Communicator, I recommend looking through those samples as well. So next, we're going to do a little bit more discussion about the HOOPS servers, because this is very relevant to what we're talking about today. So, with HOOPS Communicator, and I would say most of our SDKs, we serve multiple market verticals, multiple industries, different types of partners. And so the challenge for us is making our tools flexible. We want to be able to serve an additive manufacturing workflow. We want to be able to work inside of a PLM application. We want to be able to be inside of a collaboration app. And these are different needs for different users. Also, we need to be flexible in the way that we allow people to deploy our application. So you might want to deploy on an intranet on a local machine for a small shop. You might want to use a public cloud like AWS or Azure. You might deploy on your users who have their own private clouds in a secure environment. And so so our tools are flexible enough to do all that. And what you're going to find with the HOOPS servers, certainly this comes up often during product evaluations, is that people are a little bit confused on what components they need to use of our HOOPS servers, what are optional, how they should manage the lifecycle of the stream cache servers, should they use the HOOPS server, what about your file server? And so we'll talk a little bit about that now. You can use, I didn't say this earlier, but you can also use our web viewer without the server components at all. And that's called SCS viewing and loading. And what that does is you load the SCS file directly into the web viewer at runtime via an asynchronous, fetch, basically, just the same way your application would pull down an image. That's the most simple way to do it, but I think in production, the majority of our users use client-side rendering. So in that case, the stream cache server is the only required component of our server components. As I mentioned earlier, the way that works is you have a client application, you have a server, stream cache server listening on a port. Those two are connected together over a WebSocket connection, and then that's where the fun starts. So data stream down, communication from the client back to the web server, or sorry, streaming cache server, all of that happens over that WebSocket connection. So let's assume from going forward here that we're talking about client-side or server-side rendering, in which case the stream cache server is going to be required for that. The next thing we're going to talk about today is the HOOPS server. I mentioned it earlier. This this component is not required. Your application can choose to manage the life cycle of the stream cache server instances on its own. And we do have lots of users that do that. In the past, that was kind of more required before we developed the HOOPS server. But we also found that a lot of partners and users don't want to manage the life cycle of those stream cache servers. So we developed the HOOPS server and we deliver that. You're going to see in my implementation today that I'm using the HOOPS server, and I'll show you some different ways that the HOOPS server can be used and some different ways it can be configured. It basically works in two ways. There's one which is called the handshake mode, and then there's the one that's the WebSocket proxy mode. And I'm going to talk a little bit about that later, and I'm also going to demonstrate when using the handshake mode what the REST API can do for you and how you can start and stop this, or certainly stop this server. You can get status of how many instances of the stream cache are currently active, things like that. So we're going to talk a little bit about that. Lastly, the HTTP file server. I mentioned this a little bit on the last page, but we do deliver a sample file server. You're going to see this most in our quick start setup, and you may, if you've worked with some of my consulting engineers or you've worked with TechSoft before, or you're familiar with HOOPS Communicator, you know, or you may know that we ship with a quick start setup. The quick start setup includes all of these components, and you can run it as soon as you download and install the zip package or the installer on your machine. You can navigate to the quick start folder and you can run a shell file or a bat file to start the quick start setup. What that does is it has a file server, and then it uses the HOOPS server to start up streaming cache servers on the back end. And so that is a convenience tool. We don't recommend that people go into production with the file server. It's meant for, developing your POC, working through your product evaluation, building small demos to show other, users, or, funding demos or whatever you may need it for. We really just want to ease you into using Communicator and make it easy and quick to get started, so you can see what can the viewer do, what functionalities are available there. And then once you kind of have an understanding and see this is a tool I want to use, then you're going to move forward, and then you're going to probably ditch that file server and use your own. So what's this webinar about today? Why are we here? What are we talking about? Well, I kind of mentioned a little bit that the streaming cache server, which is actually called the TS3D SC server, that's the name of the actual binary that starts up the process. Each one of these listens on its own port. And we do this because we want applications to be able to dynamically allocate resources. So we want you to be able to start up a new stream cache server as a new user comes, make that connection, and then when that session is done, the user logs off, leaves your website, whatever that may be, and then the stream cache server realizes the WebSocket connection is disconnected and it shuts itself down. So it's a very simple process on its own, but managing multiple of those, making sure that you have resources to run a number of streaming servers on, streaming processes rather, either on a single server or by scaling up and down in Docker. We want to enable all that, but that necessitates that each of the different stream cache servers listens on a different port. And so when we think about your standard web traffic, I have a mistake here. That should say limited to port 80 and 443, not 90. But standard web traffic comes over port 80 or over 443 if you're using SSL. And most web applications, most IT groups want to keep only standard ports open to their to the backend services. And so if we were to open up, a range of ports, say, 200 ports, if we wanted to have 200 concurrent users, we would be leaving a lot of non-standard ports open, and it would probably be tough to convince your IT group to do something like that. If you're running your application completely behind the firewall, everything's internal, this may work for you. So the problem is, what we're trying to do is we want to proxy all of our traffic over standard ports, and we're going to talk a bit about that today. I do want to mention quickly, and I talked about this earlier, but the HOOPS server, a few releases ago, we also enabled the HOOPS server can proxy traffic to your backend Streamcache servers. So, but what that means is that the HOOPS server still needs to listen on a non-standard port, likely, unless you opened up the HOOPS server to, like, say 80 or 443. But then again, that's probably where your web application is going to be living, and your web server would be listening on those ports. And so then your web server would still need to connect somehow back to the HOOPS server so that it can manage the lifecycle of the Streamcache servers. By default, our HOOPS server listens on port 11182. That's configurable. You can change that, but it's still generally going to be a non-standard port. So even if we're not proxying back to each of the Streamcache servers, we're probably reverse proxying back to the HOOPS server at some point. And generally speaking, our SSL termination is going to happen at the web server or at our reverse proxy. And so, you're almost always going to have something in front of the HOOPS components to manage that kind of connecting to your web application and then accessing your backend servers. So, I've kind of mentioned this a little bit. We've talked about it. This webinar is about reverse proxies. So let's just kind of jump in and discuss a little bit about what a reverse proxy is. So, in the simplest terms, it's an intermediary between the client and your backend servers or services. So web requests come in, the reverse proxy intercepts that connection and then decides to do something. It could serve static content. It could rewrite the URL and direct that traffic to a backend server. It could be used for SSL termination, as I talked earlier, for caching, load balancing. There's a lot of uses here. And so, we're going to be talking today about IP masking or rerouting or reverse proxying. But I would recommend, if you're building out a web architecture, that you do a bit of research on what reverse proxies are used for, what they can be used for, what you might use it for. I would also have a look at some of the common software that's used. We're going to be using Nginx today. Nginx is widely used. It's a very popular open source tool. I'll be showing you that today. I'll be showing you the Docker instance of that. But Apache can do this, Apache is a very common web server. There's a plugin there that you use for that. I think it's called Mod Proxy. There's another tool called HA Proxy. AWS has a tool called API Gateway that I believe people use this for. IIS has this capability. And I'm sure there's a number of other tools that I don't know about on your public cloud providers that can do this kind of routing for you. So yeah, do a little bit of research. Look at the cloud you're looking at, cloud service you're looking at, engage with some experts there on those teams, and figure out kind of what the best tool would be for you. But again, we're going to use Nginx because it can be run with AWS, with Google Cloud. It can be run on your own machine, and so I feel like it's the best generic example, and that's why we'll be using that today. So again, we're going to be talking about incoming our requests from the user and rewriting the URI to connect to a different backend streaming cache server or the HOOPS server. And I'll just pause for just a second. Gabe, are there any questions in the chat or anything I should be aware of?
Not right now.
Okay, thank you. Yeah, feel free to put questions in the chat if you have any. Let me know if I'm going too fast, I need to slow down, you want me to go back and look at another slide or anything like that. So, okay, so now I kind of want to talk a little bit about the web architectures and some sample architectures, and then kind of specifically the architecture I'm going to be showing you today. So there are many ways to skin the cat. There's many paths to your destination when it comes to building out a web architecture, and you're going to have different components, different architectures, depending on a number of things. What is the use case for your tool? How many concurrent users do you expect to have? What's the size of the data that I'm going to be serving up? What's the usage pattern of my tools? Do I expect large spikes, or do I kind of have an idea of the number of users that connect on a daily basis and that doesn't change often? These are all considerations that you need to think about when you're diagramming a web architecture. You also want to think about what are the cloud service providers that I'm using and what tools do they have available to me. People often ask us about Azure setup, Google Cloud setup, AWS setup, and what I can say is that no one on my consulting team is an expert on any one of those. We have a lot of different knowledge in the team about those tools, and we'd be happy to discuss that with you. But usually what I recommend to people is sit down, plan out your architecture on paper, then kind of try to look at, say, okay, if I feel like I need a load balancer, does AWS have something for that? If I need a reverse proxy, do they have a tool for that? I want to manage, containers. How do I do that? What is Kubernetes? How does that work into my architecture? Or can I manage that directly? Or am I using containers? If I'm using EC2, what's an auto-scaling group? There's a lot of tech here, and I think it's easy to get caught up in the architecture. So what I do, and what you're going to see here, is we're going to start with a simple architecture. We're going to build that out, build our proof of concept, and then we're going to decide what works in that architecture, what needs fortifying, or now I know more about the tool and I know a little bit more about my usage patterns because I've talked to some of my customers, so maybe I need to adjust that architecture. So that's how I approach these types of setups, and I talk with our prospects and our partners when they're discussing building out a web architecture. What I also recommend to people is you can reach out to my team, the consulting team. You can, I would recommend you, if you're not a member of our forums, join our forums. We have a lot of knowledge base articles there, specifically covering reverse proxies with different technology, setting up SSL, questions about this. This is the type of question that you could pose in our forum, and you'd get a lot of feedback from, experienced users of ours, people at TechSoft, developers, support engineers, things like that. So those are all resources to you to help you plan this stuff out. So what we're going to do today is, this is kind of what you're going to see today, something similar to this. What I want to talk about here, so we've got this kind of set up here as well. I've got our external users, Janet, Karen, and Bradford. They are connecting to our web application via web server. That web server is going to go through to the proxy, and then the proxy is going to decide what type of web connection came to me, and it's going to make a decision there. Either it's going to go to the web server through the API if we're using the handshake mode, and it's going to ask the web server for a URI for a server that's been started that it can connect to. So in that case, we'll see that we're going to connect the Nginx here. We'll connect to the HOOPS server, which will start an SC server up on the back end, and then reply back to the reverse proxy with the URL that needs to come back out, which will then be passed back out to our web server web application, which will then start the web tool, and then again connect through the proxy to that backend server, so that we're all going over standard ports. So that's kind of one way that we're doing this. The other way that we're doing this is, so quickly, before we move to the next slide, I do want to talk about, I have everything laid out as discrete components here. You're going to see today that my web server and my reverse proxy are one and the same. I'm using Nginx to do both. You could do that in production, or you could use Nginx for your routing, and use another technology for your web server. It's up to you. You may even have two instances of Nginx running, one on one physical machine and one on another machine that I think is a proxy. So there's a lot of ways, again, to do that here. I just want to point out that in the example you're going to see today, these are not discrete. Also, what I wanted to point out in this diagram is that this diagram is combining two different ways of using the proxy and the tools. I kind of described them both there. One is the handshake mode. That's our REST handshake mode. And one is the WebSocket proxy mode, which we're going to see both. We'll see an example of both of those. In the WebSocket proxy mode here, if we were to just put that down on paper, that would look something like this. So we'd have our end users coming through to the web server, which would go through to the proxy. And in this case now, our reverse proxy is literally only proxying one port, and it's going to proxy to the HOOPS server on the back end. You don't even really need to do this. If you could, if you wanted to, you could leave the HOOPS server port open. So you could have port 80, 443, and 1182 to the HOOPS server open. And you would then not need a reverse proxy here. But that would mean that your HOOPS server is open out to the public, and people could, write they could ping that server, they could write URL requests to that server, they could post to it using Postman or some tool like that, curl or something. Now, you might not want that. When we think about security in the web, we think about limiting our ways into the back end, and generally speaking, keeping things on standard ports that we know are secured by tools that have been around for a long time. And so the way I would recommend doing that is you have your web server, your reverse proxy, and then all of this stuff on the right of the reverse proxy is behind the firewall and behind the reverse proxy and can only be accessed through the proxy. And so the way this works is proxy, again, it just goes straight to the HOOPS server. And instead of making the REST call to it to say, hand me back a URL to a running Streamcache server, what I'd rather you do is just start the server up for me and connect me straight through. And so again, we're proxying twice here. We're proxying our connection from the web server, which is going to the HOOPS server with just one URL for all of your connections through there. And the HOOPS server is managing starting and stopping these, and then proxying the connection back through here, which proxies back to the web server. Again, we haven't really talked a little bit about this, but then there's a lot of options here for storage. In this case, we've got one large network attached storage. This could be an NFS on AWS. This could be just a big giant RAID in a private cloud or something like that. You could also have multiple storage appliances, or what a lot of people do is they keep their files in cold storage, like S3 buckets, and then at runtime move them over to a more fast network attached storage that's only attached to your specific Streamcache server or something like that. Lots of ways to do this part. We're not going to talk too much about it today, but again, I just want to reiterate that things are flexible, our tools are flexible, and there may be a better answer for you, and what you're seeing here may be a bit too simplistic for your application. Again, here I'm just talking about the two different proxies, and I mentioned the need for both, or you may not use them both. Again, up to you. So before I move on to the exercise, just want to check again, any questions? Looks like maybe I see something in the chat. What is this?
Oh, it was just me sharing the form link with everybody.
Okay, perfect. Just want to make sure I wasn't missing anything. So feel free to interrupt me, Gabe, if I do miss something. Okay, so what I want to do today is walk you through a sample setup that I've built using Docker, Nginx, and HOOPS Communicator. So for those not familiar with Docker, it does kind of OS virtualization it makes what we call a container. These containers are portable. They can be run, in multiple environments. They contain all of their resources that they need, all of the anything they rely on, libraries, specific versions of tools. All of that is built into an image, and then the image becomes container. As it's instantiated, becomes containers. You can run multiple containers. They start and stop very quickly. Again, I mentioned they're portable. And what else is nice is for development, for example, like building an Nginx demo here, I don't need to install Nginx on my machine and then figure out how to configure it and then figure out how to open ports and things like that. I can just pull an image of Nginx off of what's called Docker Hub. So let me just quickly jump over to my web browser here because I've got a few links that I want to show you. So if you're not familiar with Docker, it's a useful tool. It's used all over the web. It's used for development purposes as well. It's really useful tool. I use it a lot because I can quickly instantiate different versions of, like, say, Linux that our partners are using. Some people use AWS Linux on AWS. Well, that's great because Amazon posts an AWS Linux container on Docker Hub. And what that does is it allows me to build on my local machine using AWS Linux right here, and know that when I do move over to AWS Linux on, say, EC2 or Docker or something over there, everything should work because I'm using the same version of Linux, which is nice. These images are maintained by different organizations, different open source communities and things like that. And one of the things that's on here, and you may have seen this right when we got here, is Nginx. Nginx is actually, I think, the second most popular used Docker image from Docker Hub. What's nice then, I can just, on my machine, if I have Docker running, I can issue a command Docker pull right here. So you see Docker pull Nginx. It will pull this image down onto my machine. Now I can use it. I can just start it up as is and not do anything different. So, these images down here, they give you some sample how to run them. So I could just say right here I can create a Docker file if I want. And I could say from Nginx, meaning use this Nginx image. I want you to copy static files from the directory that I'm my working directory into the Docker image. And then when the container started up, it will listen on a port. In this case, they're going to forward 8080 from my host machine to the Docker image on 80. And now I have a web server running with Nginx. It takes 30 seconds. It's really easy. So if you don't know about Docker Hub, you don't use it, I highly recommend you do. Check it out. And that's what we're going to be doing today. So this is the base image that I'm starting from, so that just so we're all clear. Then I want to, let me go back here. Then we're going to go through some configuration files, how I configured Nginx, how I configured HOOPS server, and then I've got two different setups here that we're going to look at, using the REST handshake mode and using the WebSocket proxy mode. And so we're gonna do that quickly here before we get started. I'm gonna give everybody a link here. Oh, it's in my notes. I don't know if I can get to it. Let me just come over here. Oops. Here we go. So in our documentation, we've got pretty good docs that walk you through all of this. So I'm going to drop this into the chat. So it'll be available for everybody for review. This kind of describes what I just went over, but with a little bit more detail. And so you should get yourself familiar with this, but we're going to come to the HOOPS server today and basic configuration here. And we'll be talking about all of these different components, how we set everything up. And then we'll talk about the stream cache server and all of that. So be familiar with this documentation. You might follow along in here. If you have questions, it could be answered in here. So, okay, let me move on to the exercise here. I'm going to be using Visual Studio Code. I will open this up. I've tried to make this big enough so that hopefully everybody can see what I'm doing here. But we're going to start with the Docker file. So I'm going to provide this. I'm going to provide this entire setup for you. It's very small. It's 10 KB. And when you do this, if you unzip this and you run one or two commands, everything will be enabled for you, and you can have an example setup. You can investigate how it works, and then you can ask questions. And there will likely be a forum post that we will follow up with here, so I can answer questions there. But what I want to show you is when you unzip the zip file, if you just choose to use this after today's call, you will be presented with a folder like this. You're going to have content. It's going to have 3 files in there, 2 HTML files and a JavaScript file, which we'll look at in a second. There'll be an empty HOOPS Communicator folder. All you need to do is drop in a HOOPS Communicator package. It needs to be HOOPS Communicator _something_linux.tar.gz. And the reason is because I'm grabbing that right here in the Docker file. It's not limited to a version, so I've written it in a way that you just drop in the GZ file into this HOOPS Communicator folder. This is on your host machine, so on Windows or your Linux host before you start Docker. Once you do that, you can just run this build command, and it will build the image for you. And then from there, you can just run this run command, and it will run the image and put it in the background, and it will start for you. And you will have an image in the background running, and it's listening on the port 80. And we're going to see that here in a second. So that's all you have to do. You know, from there, you can just work with it as is. You can develop against that server if you'd like, or you can stop it, make some changes, and restart it. Or you can run the Docker in an interactive mode and play with it that way. But real quickly, I just want to go over this Docker file. What I'm doing here is I'm using that Nginx container, the official container I pulled from Docker Hub. I'm setting the working dir to my /app inside of the Docker container or image. I'm copying content over, so I'm copying content from this folder here. And in this case, what I'm copying over is the 2 HTML files and JavaScript file to my static content where I'm going to serve up as my web server from Nginx. Then I've got a custom configuration, which we're going to look at in a second. I'm overriding the configuration that's shipped with the official Docker image. And then I'm going to copy HOOPS Communicator, the GZ file rather, into the /app folder so that I can then start working with it. Now, this is a runtime command, meaning when it starts up, I'm gonna find whatever version of Communicator that you put there, and then I'm gonna untar it by passing it to xargs, which, you know, so that way I don't need to know the specific name. We're gonna untar, unzip it, uncompress it, and then I'm gonna remove that GZ file. And then I'm just going to rename whatever that folder was to HOOPS Communicator so that it's more simple going forward to work with. Then I'm going to copy over the custom configuration file, the JavaScript configuration file for the HOOPS Communicator into the quick start, because that's where I'm going to be running the HOOPS server out of. Instead of running it, I could run this from another location using Node directly, but it's already all set up in there. So I'm going to run the HOOPS server from there. And the only configuration change I really made here is that I turned off the web file, the HTTP server. But I'll show you some other things you could change in there if you wanted to. Next thing I'm going to do is I'm going to then copy HOOPS Communicator web viewer JavaScript source over to my static content folder, because these HTML files need those files to run the web server. So that's all the code that runs the WebGL web viewer in a web app. And then the last thing I'm doing is I created this little convenient shell file, and I'm going to put it inside of this entry point here that will automatically start. So it will automatically start the server up once I run it. And then, so when I then instantiate this container, Nginx has started and HOOPS Communicator started, and everything's just waiting and ready for me. So any questions about that? I don't see anything in the chat, but feel free if something's not clear about what's going on there. Okay, so let's look at the kind of Nginx file here, because this is really probably the most important thing to look at today. So this file, there's some basic stuff up here on top. I'm, configuration for Nginx. This is all standard. Where right here is kind of where my definition starts. So my configuration starts. So I'm starting a server. I want to listen on port 80. You could also listen on 443, and this is where you would configure your SSL. And at the end here, I will show you some links to knowledge base articles that show you the next steps there on how to set SSL up with all this. So you can continue your learning if you'd like. Okay, what I'm doing here then is I'm telling it that here's the root of my web server, and that's where we copy those HTML and JavaScript files. And then from there, I'm gonna proxy through the traffic. So when I get a request here that has /API proxy on it, I'm gonna intercept it. And then what I'm doing is I'm intercepting it here, and I'm rewriting the URL. So I'm doing a quick regular expression, which has two capture groups. It says, I want to capture API proxy, and then I want to capture whatever's here. And this should be a port number. That's what I'm looking for, /D. And I need one or more of those up to the next slash. So capture the whole port. And then from there, capture anything at the end of that and place it at the end of the URL here. So what I'm going to do is I have two capture groups. I've got the port and then whatever else I'm proxying through, and I'm going to pass that through to this backend server here, which will be the port, and it will add the slash on here. So what this would look like in reality is if I said localhost /API proxy /11182 /API/help, which you'll see in a second, this would proxy through to the localhost 11182 /API/help. So it's just rearranged the URL, and then it's passing it through back to the version of the URL that the HOOPS communicator will understand, the communicator server. So now the communicator server can respond to that REST API. So this is why I'm calling this API proxy, is these are my REST commands I'm gonna proxy. Down here will be the proxying for a WebSocket. It's a very similar thing. I won't walk you through this regex again, but WS proxy, and then I'm capturing the port and I'm rewriting it to here. A couple of things different here is I'm going to do an upgrade to a WebSocket connection. You can read about that with Nginx proxying if you'd like. That's it. Pretty straightforward here. So that's the server there. Okay, the server config for for the HOOPS server has a whole bunch of configuration in here. I could change the port here for my HOOPS server. I can put a public host name. That would be for SSL. You would need that. Lots of configuration here. Enabling SSL, CSR. I could disable SSR if I don't want people to be able to use it, things like that. But at the bottom down here, I put my license file here. And then up here, what I'm doing, the config, is I've just basically turned off the file server. And it says right here how to do that is by setting this file server port to 0 so the server won't start up. That's the only thing that I've done differently there. Okay, we're going to look at this code just briefly here. This is a little helper code for if I'm using the server in a handshake mode. And this is a little class that all it does is make a connection back to, and you'll see this in a second, to that port, that API proxy port, so that I can proxy my REST calls back to the backend server. And then this starts this waits for the HOOPS communicator server to start up a server, and then the server will respond with a URI. Then that's what this gets back from there, and then it resolves a promise when it's ready and pass it through. I've made some changes. This is in our documentation, but I've made some changes here that I'm rewriting this with a JavaScript regular expression here. I'm rewriting the way that this proxy URL looks. So now I'm rewriting in the opposite way that I did in the Nginx configuration. I'm getting a URI back that has a port on it, and I'm rewriting it back so that it's a WS proxy port. And what's nice, so then that will be passed back out to my outside application, which will then connect back through all of the proxy here. So it's this kind of like circular setup that we're doing here. Okay, enough talking about that. Let's run this. So what I'm going to do is I already have built this image, and I've already run this container once, just so we're going to skip that setup, but I'm just going to go ahead, and run this server. I'm just going to start this stopped container. So I have a container called HC-Nginx that I built earlier and I run it earlier. So, and then I just stopped it. I'm just going to start it back up, and it should start up here. There we go. Let's make sure it's starting here. It's taking a sec. Let me try to start that again. There we go. It goes very quickly, and then it'll just spit out the name when it started up. And that name, if you didn't specify a name when you started it, this would be like a hash, and that's how you can start and stop or delete or remove the container. So now let's come back here. Okay, now what we've done is I can go to localhost/dev.html. I know this is hard to see. I'll make it bigger. Okay, I'm going to make this bigger here. And then I'm going to open up the debugger and we can see what's going on here. So, okay, now let me make this bigger as well for you. Okay, so now this will make a little bit more sense. What you're seeing here is the handshake mode. So I'm going to reload this page and we're going to stop here and we're going to see what happened. So what happened? When I on load, I made a call to using that server connection JS file that I showed you earlier. I made a call to the backend. I passed in, you see, I passed in the proxy URL because all my traffic's going to go through the proxy now. I can't access localhost:11182, but I can go through the proxy now. And so I'm proxying this connection back. This is going to go back to the server connection, which is going to post that out, which will go through the reverse proxy, will then hit the HOOPS server. The HOOPS server will respond back. And what does it respond back with? In this case, it responded back with an endpoint URI here. And that is rewritten, you see. So WS127, so localhost, reverse proxy, and then the port that it was started up on. And that happened here in this response text. I got the response back from the HOOPS Communicator port or server, which was, web ws//localhost:port, and I rewrote it as ws//localhost ws/proxy port/port. So then we're back here, and that's what we have here, right? Okay, so continue on. So now, okay, great, everything's loaded up. We're running, boom. This is great, right? Now, I want to show you something else. So we can also go to localhost, and I can go to API proxy. And so what I've done here, I'm not using my application. I'm just showing you that I can go through my proxy here. So if you start up the HOOPS Communicator server on your localhost machine or the quick start, you can go to localhost:11182/API/help, and it will print out this for you. And so that's what we're doing here. And I'm just showing you that here's the URL that you would call if we weren't going through the proxy, right? But since we're going through the proxy, these have to be rewritten as API proxy port, then the last bit of the URI. So that's going through here. What I want to say is I'm doing this in demo here. For production, you wouldn't really want to pass this stuff through. What you would do is change this configuration a bit so that you didn't pass through whatever was after here. And I can show you that at the end if we'd like to discuss that, but you really just want to proxy your port number because you don't want people to be able to go through the back and like poke around at your REST server. But for this demo, you're going to have access to that. And I wanted to show you that. Now, we're going to do one more thing here, and then I'm going to open it up to questions. So the next thing I want to show you is I have some more code here called, this is dev HC-prox. So now we're using the proxy set up in a different way. I'm still going through Nginx, but in the case, if I were to run it this way, I could choose not to proxy the API calls at all. So get rid of that location for the /API proxy. And I could just rely on HOOPS Communicator server to proxy my backend connections to the Streamcache servers. And in that case, this makes it very simple. So I still have a proxy here for Nginx, but only for WebSocket traffic. So my web app comes through and it still starts up a server, and all I ever have to do is put in this URL. And when I put in this URL, it's going to go through my Nginx reverse proxy. It will rewrite the URL to localhost :11182, and then the HOOPS communicator server will see that you came in on the WebSocket instead of HTTP, and it will know that you want it to proxy the traffic for you. It will start a stream cache server for you, manage that, and then proxy back through just the 11182 port, which will come back through your reverse proxy and then connect you directly through here. And so this is, I think, the way that majority of people are going to set up and run the HOOPS communicator server with a reverse proxy in production. Okay, I covered a lot there. There's a lot of moving parts. I've covered a lot of different things here, but I want to leave the last like 10 minutes here. We got 8 minutes. I spoke a little too much for questions that people may have. So please, does anybody have any questions for me? Or compliments? I take those as well. Okay, so then we're going to go back. I'm going to jump back into the slides here. I do want to leave you with a few more things here. So the last thing that you should do on the next steps here is you should be looking at running this sample that I provided you. Then you should come to in here and look at some of these are links to knowledge base articles on how to set up a reverse proxy with AWS, how to set it up with IIS. As I mentioned earlier, the next steps was setting up SSL in NGINX. In this case, we're doing on AWS. Basic SSL setup with HOOPS Communicator in NGINX. Like I said, there's a number of different articles you may be interested in looking at. And then again, some more links here for some of these we looked at. Server documentation. We have some deployment scenarios that we talk about in the docs. And then again, connecting to the HOOPS server here. We've got some of those NGINX configuration files are listed in our documentation. They're not the exact same ones I wrote. I'm actually going to ask my learning team to update them with the versions I have, as I think they're a bit more flexible. But either way, you can get a really good starting point and idea from our documentation. So that's all I have today. I'll hang around here for 7 more minutes, see if we have questions. And I hope people found this useful.
Thanks, Robert. And I'm just posting links here in the chat to the things you mentioned. The recording will be available. Usually that takes like 3 to 5 days after this session, and it will be posted on our forum. In addition, you should also get an email with that link. So just be on the lookout for that if you want to take a look back at this for any reason. And I don't see any other questions, Robert. I'm going to continue posting all these links in the chat.
Yep, absolutely. And since I'm going to make this a little smaller, and maybe we'll come back in here and look a little bit more at this. So since feel free to ask questions, but I'll just kind of talk through a little bit of this. So let's compare these two side by side here. So what are the differences between?
Share your screen.
Oh, I'm not sharing. I unshared it. Let's do that again. Thanks, Gabe. Okay, so we'll jump back in here to, and what I want to point out is I've pulled these two files side by side so that we can look at what are the differences between what's going on with, these two. So in here, we actually don't even need this anymore. But so, the difference between when the two ways we're connecting here, so on the left, we're using the handshake mode of the HOOPS Communicator server, and on the right, we're using the WS proxy mode. And so on the left, the difference is that we are using this server connection.js utility to make a call out to the communicator server. We expect a URI back, a dynamically generated URI back, which then we place in the communicator server when we start the viewer. So that's handshake mode. When we're using the WS proxy mode, we're not making an initial call to the HOOPS Communicator REST server. We are just starting our HOOPS viewer with a WebSocket localhost connection with a port 1182, which is what our HOOPS Communicator server is configured to listen on. By doing this, the HOOPS Communicator server just says, oh, they just want to make a direct connection via WebSocket connection. So I will start the the streaming cast server on the back end, and I will handle that traffic between myself and that, and I will proxy that back through to the web viewer. This is more simple use case here. The one on the left is a little bit more flexible, and also by doing so, we are making proxies for our API. So if you want to be able to proxy your API traffic through, you can do that. We could, running in the WebSocket proxy connection, we don't need this rewrite rule. We just literally need one rewrite rule in our Nginx configuration if we're using Nginx here. Great. Okay. Thanks for posting those. Well, I don't have any, that's all I have today for everybody. Hopefully that's been useful. Gabe will make sure that that the zip file with all of this Docker configuration and everything is available to everybody. And I would encourage you all to run it and get familiar with how these work. It seems a little more complicated than it is, but I think once you understand all the discrete components and how the back and forth works through the proxy, it's actually pretty simple.